Dear students, now today we are going to discuss about numerical differentiation by using Newton backward interpolation formula. Let us look what is the numerical differentiation. Of course, we have already seen about the numerical differentiation by taking the Newton forward interpolation formula. In the similar manner, the derivative using backward difference formula we can obtain. So here we may consider the function y is equal to fx, which is tabulated for the values xi, where I varies from 0, 1, 2, and so on. So according to Newton's backward interpolation formula, you just once again you remember y is equal to yn plus p del yn plus pp plus 1 by factorial 2 del square yn and so on. Now you can differentiate very easily as per the Newton forward interpolation formula, and you will get dy over dp, that is del yn plus 2p plus 1 by factorial 2 del square yn plus 3p square plus 6p plus 2 divided by factorial 3 del cube yn and so on. Now, since P, you know, in case of backward, P is x minus xn by h, and therefore dp by dx is very easily, you can obtain the value of this is 1 by h. Now, dy over dx, you may write dy over dp into dp by dx. It means here you will get dy over dx is 1 by h del of yn, backward del yn, plus 2p plus 1 factorial 2 del square yn, and so on. So at x is equal to xn and p is equal to 0, you may put, if here you take x equal to xn, then p is 0. It means by putting this, we will get dy over dx at x power n. And the formula will look like this: 1 by h del yn plus 1 by 2 del square yn and so on. Now, if you continue, then you will get d2y over dx square is equal to 1 by h and 2y factorial 2 del square yn and so on. It means from here, it is easy to write here q1 by h square del square yn plus del q yn plus 11 by 12 del power 4 yn plus 5 by 6 del power 5 yn and so on. And further, you may get the cube dq over y over dx cube is equal to 1 by h cube del q backward del q yn plus 3 by 2 del power 4 yn and so on. Otherwise, as discussed in the forward case, here also by taking use of this formula, 1 minus del is equal to e power minus n, and this is equal to e power minus hd, where d is the difference operator. So by taking this, d is equal to, you will get 1 by h and del plus del half of del square backward del square half of 1 by 3 del cube plus 1 by 4 del power 4 and so on. In this way, you can derive this formula, and you will get dy over dx at x power n is equal to 1 by h del yn plus half of del square yn plus 1 by 3 del q yn and so on. Now, similarly, you will get in the similar manner by taking the operator only, you can establish the same formula which we have discussed in this case, in this particular case. Now, for example, let us take our problem. X is 1, 1.0, 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, and y is 7.9, and this it is given that. Now you have to find what is the dy over dx and d2y over dx at a given value x is equal to 1.6. 1.6 is here, and it is required the derivative. It means by using Newton backward difference formula, we will find the derivative. Okay, so first we will create the backward operator table, difference of table. So this, you know, y is given. So here del y, you know, this is the difference between this. This difference is this you got here. Then similarly, this difference is 0.378, then 0.348, this difference, and then 0.322 and 0.299, and this difference is 0.281. Again, similarly, this difference, this indicate minus 0.037, as this is 0.414 minus 0.378. Okay, so this minus this minus this, it means this minus this is minus, and similarly this minus this is again you got this value, that is minus 0.30, and then minus 0.026, and this is minus 0 by 0.023, and similarly you will get other values. Okay, so here also it is only minus 0, minus 0 point, this is point, this is a point 0 to 3. Similarly, you will get here this is and this value. Okay, if you take the difference of this, and similarly here the difference of this, then you will get 0.006, because minus 0.030 and plus 0.036, you will get 0.006. Okay, so now the difference of these two, you will get 0.004. The difference of these two, you will get 0.003, and then again the difference here you will get minus 0.002, and here minus 0.001, and this difference gives you 0.001, and here also further you will get 0.003. Now the difference of these two, you will get 0.002. So in this way, in this way you can prepare the difference table, and now after putting all the value here, you will get all the value. You can put here the values, and then the values are already here. Here from the table, h is 0.01, xn is 1.6, del yn is 0.281, del square yn is minus 0.018, del cube yn is 0.005, del power 4 is 0.002, del power 5 is 0.003, and del power 6 is 0.002. In this way, dy over dx, you will get at 1.6 is 2.75. You have to calculate it. So please calculate the value. Don't believe if this is correct. Only you listen, make your concept clear, and then you devote much time to practice all these things. Don't expect everything will till here, because this is your turn and you have to do much practice for all these definition, formula, and the numerical problem. Now, similarly, you can get d2y over dx square at xn. You can find out this formula, and after putting all these values from the table, here after simplification, you will get 0.715. Okay, thank you very much. Thank you. Stay safe.